Hey guys, we are starting chapter 11, and that's kind of exciting because it is a topic that typically ends our pre calc book. And so, what we're really doing now is paving the way for you to be in a calculus class. So, whatever the future holds for you, I assume since you took pre calculus, you're at least considering a calculus class somewhere along the way, either willingly or against your will. So, it's kind of starting now. It's going to use a lot of concepts we've used in the past, but we're smart. And so that's a good thing. We can finally put them to use. So, what we're going to be looking at now is limits. The limit of a function kind of describes what it goes towards. Like, what does it approach? And there's a variety of way to find the limits depending on the function. If there was just one way that worked for everything, I would show you that, but there's not. So today you can see we're going to be looking at direct substitution, graphing, and tables because those are the first three that you always kind of try. And then we'll be looking at some more complex things as we go because I know you love complex things. One of the things that makes this a little tricky to students is just the look of the question, kind of like logs. The questions aren't hard, but they look a little weird. So this is what a limit question looks like. It'll always say LIM for limit. This is asking you what is the limit of function, whatever. So right here, you're going to have like a rule or a formula or an equation. Like here, it's 2x plus 1. Here, you've got the x squared minus 4 over x minus 2. So it's going to be the limit of whatever function they give you. Here's going to be telling you what x is doing. So as x goes to c, whatever that number is going to be. So as x does something, the answer is going to be asking you, what does y do? What does y approach? Now, it may never get there, and we've seen that with asymptotes where it can go towards an asymptote but maybe never touch it. So you're really saying, hey, if I'm looking at this function, as x does this, what does the y go towards? What does the y approach? Or what is the y pointing at? So we're going to look at three possible options. One is direct substitution, which is exactly what it says. So for this function, if it's asking me to find the limit of 2x plus 1, that's my f of x, as x goes to 5, it's asking me what y value is it going towards. So we're looking at direct substitution. We're looking at graphing. And we're looking at how do I use the table on my calculator. So this one's pretty easy, so we're going to start with that. To find the limit using direct substitution, you do exactly that. You take this 5 and you plug it in for that x, and you'd say, okay, well, as x goes to 5, so here's our x, 1, 2, 3, 4, 5. So as it heads that direction, where will I be in terms of a y value? And the answer is 11. So apparently, according to this function, when you are at 5 out here, you'd be approaching 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So really far off this chart. Okay, so using that method, my answer is 11. Well, that's easy, plug it in, but it doesn't always work. So another option you have is to graph and then use what we call a value function on your calculator. So I would go to my calculator. Mine's pretty tough to see with the big old blob and reflection, but we'll do our best. And I type in the equation, 2x plus 1. And I want to have it without any zooming in or out, so I go to zoom 6 and make sure that I'm just starting with regular graphs. Not super surprised because I'm in pre-calc, so I know that 2x plus 1 is a line. So on here it would cross at 1 because just mx plus b, up 2 over 1, up 2 over 1, up 2 over 1. And then I would connect those dots to give myself a nice line. But I don't have a straight edge, so I guess I won't connect those dots. Okay, I'll do the best I can. So then what that's telling me is if I followed that line off the paper to get towards the 5, where would I be in terms of a y value? So again, I'd be coming up here towards 11. Now, if I didn't know and it wasn't easy to tell, I could go into second trace. And when I do second trace, I get a bunch of calculate options. And so I'm going to choose value because I'm looking for a value. I'm looking for what value does this function have as x approaches 5. So I'll type in my 5. And then when I hit enter, it's going to tell me the y would be 11. So that would be a second way I could find this answer. And you might be thinking, I'm not going to do a bunch of ways. Well, I get that, but sometimes this doesn't work and you're forced to do graphing using the value function. But sometimes that won't work, so we're going to have to use a table function. So learning some more keystrokes, and it might be smart to write these down so you can do this later. I'm going to go to the table function of my calculator, but first I'm going to set the table, just like you would if you were going to eat. So I'm going to go second table set. I want my table to start at the number I'm curious about. So I'm going to do a table start of 5 for this particular question. And then I want to close in on it. So I don't want to use big numbers. I want to close in it. This delta table means what do you want to count by in your table? So like when you guys used to make XY tables, you know, if you did X's, you would do like 1, 2, 3, 4. But if you really wanted to get in at better data, you would maybe do 1.1, 1.2. We don't want to plug those numbers in, so we're going to let our calculators do that. So we're just going to change by 0.1s. Now when we go back to second table, I can actually see the values, and I'm going to scroll up a little bit because what I'm curious about is at 5, and I can see that as I look at the numbers from each side, these are getting bigger towards 11, these are getting smaller towards 11, so they're kind of pinching in or approaching that 11 right at 5 again. So there's 3 ways to get that 11 as the limit of my function. So let's take a look at the second example, and maybe we can figure out which way we have to do. Easiest is direct substitution. So I'm trying to figure out what this function does as x approaches 2, so I'm going to plug in a 2. 2 squared minus 4 over 2 minus 2. Big trouble, double trouble. Got a 0 on the top and a 0 on the bottom. That is not really undefined, it's just indeterminate is what we call it in calculus, and that's where we're headed, so we'll use their language. It doesn't really tell us anything. Like I have no idea what's happening as x approaches 2. So I'm going to try out my second option. I'm going to go ahead with my graph and then value function. So if I go to y equals, keeping in mind that when you're entering this, you do want to be careful to say, hey, this entire thing, the x squared minus 4 is on the top, and then I'm dividing by this entire thing, this entire thing, x minus 2 on the bottom. Zoom 6 so that I can look at the beginning or the regular part. Looks like a line. But when I try to go to second trace value again and put in the number that my x is approaching, which is a 2, when I hit that, I have an x value of 2 and a y value of nothing. They don't give me a solution because 2 minus 2 is 0 on the bottom, and that is not defined mathematically. So I have to go back and try my third option, which is going to be resetting my table for this situation. So second table set, I'm interested in what's happening around the value 2. And again, I want to keep this number low so that it's closing in around that 2. So second table, I want to see the table. And then I scoot up a little bit and then I look. See how there's an error? That's because when you plug the 2 in, you get a 0 on the bottom. So you get an error on your calculator. But I can also tell by looking at the numbers below it, 3.7, 3.8, 3.9, and coming in from the other side, 4.3, 4.2, 4.1. So it's closing in or approaching a value of 4. So I know from this third way of doing it that the limit of this function, x squared minus 4 over x minus 2, as x goes to 2, the entire function approaches a y value of 4. So you're not going to have to do all 3 ways. You're just going to have to know how to do all 3 ways so that you can look and see which one works for you. So this is a piecewise function. Those are really tricky to graph on your calculator. They're really tricky to graph on paper for some people. Plugging in a 2, I could try that, but you have 2 different rules, and this is the only one that allows you to plug in x equals 2. This one's for x is greater than 2, not or equals 2, whereas this one would be greater than or equal to. So it's tricky to plug the 2 in because you can only plug it into part of your piecewise function. So the way I've always thought about these is I'm going to do each rule. To the right, where x's are greater than 2, I have the rule x plus 3. So I'm going to pick maybe just two numbers. I'm going to pick the 2, even though I know I'll have to have an open circle there since it's greater than but not equal to 2. Plugging it in, 2 plus 3 is 5. And then I'm going to pick one other number, let's say 3. 3 plus 3 is 6. So at 2, 1, 2, 3, 4, 5, 3, 6, plus this has a slope of 1, so I know it's just going to keep on going that direction. That's one piece of my graph. How about the other piece? So same thing. That's for this side. So I'm going to pick a number or 2 that's on that side. I'm going to pick 0 and I'm going to pick the 2. So if I put in a 2, I'd get negative 2. If I put in a 0, I'd get 0 again because there's no such thing as negative. So that one's going to be at 2 right here. Oops, sorry, that would be at negative 2 and at 0, 0. Well, that makes sense too because I know that this line should be sloping down 1 over 1 from the left. So down 1 over 1, down 1 over 1, down 1 over 1. And since it's not plus anything, there's no b value, meaning it crosses at 0. So here are the two pieces. So what's tricky here is if I'm trying to see as x approaches 2, which is right here, what is the graph approaching? Well, from the left, the graph of f of x is approaching a negative 2 for the y value. And from the right, it's approaching, as I come in from the right side, the function, the y value, whatever you want to call it, is approaching this dot, which would be at 5. So when what you have happening from the left does not equal what you have happening from the right, then the limit of this function does not exist. And so my answer up here to finding the limit of this function as x goes to 2, I would have to say, I wouldn't really say no solution. That's not how you write it in calculus. You write that the limit does not exist. Kind of a separate terminology. So like if they had asked me about something over here, then I could see that from the left and right, I'm approaching that value of 1. Over here, I'd be approaching that value of 6. But because they picked 2 right here, they don't approach the same number, so the limit doesn't exist. Okay. Hang in there with me for a couple more kind of kooky examples so that you have some more experience. Here, if I want to use direct substitution, I'd have 0 over the square root of 0 plus 1 and then minus 1. That's going to unfortunately put me at 0 over 0 again. So that's not really giving me any information. So I'm going to go ahead and graph it. I'm going to have, go back to y equals and clear that out. I'm going to have an x. And then I'm going to divide it by, and I'm going to be real careful here because I need a set of parentheses because my calculator is a little older to let it know that this is the bottom. And the bottom for me is going to have a square root of x plus 1. Now mine's older, so I have to close that parenthesis out for the square root sign. And then minus 1, and then another parenthesis to close it out so it knows that whole thing is the bottom. When I zoom 6 that, I see my graph. And I kind of have this going on. I'm interested when x is 0, which is right around here, but I'm going to go ahead and try my second trace value for when x is 0, because that's what I'm plugging in, and I don't get anything. So when I use my graph and then my value function, when x is 0, y is not defined. So that's not conclusive either. So I go to my third option and I'm going to set my table. I'm going to set my table around the number I'm interested in, which is an x value of 0. I'm going to let it count by small numbers still. And then I'm going to look at my table by going to second table. I like to scoot up a little. And now if I look, these numbers, 1.989, 1.94, those are approaching. It looks like a 2, and from the other side, it's counting down 2.14, 2.09, 2.04. It's pinching in towards a value of 4 where this error would be across from 0. So according to the table, I would write the limit of this function as x approaches 0 is going to be 4, because that's what the y's are approaching in my calculator, as the x goes to 0. Okay, so let's take a look at this. I don't really want to, plugging this in won't help because I'll have 0 over 0. And so I'm going to try, I'm having trouble with my focus here. I hope you guys can see this well enough. All right, that's actually a lot better. Don't you wish I did that 10 minutes ago? Okay, but that's inconclusive. The graph is probably going to be inconclusive, but I'm going to take a quick look at it anyway. So absolute value for me is found if I go to my math key. I have to go over to numbers, and there it says ABS. And so that's for absolute value of x. And then I have to close my parentheses. Some of you get the fancy lines, and you can just put it in there. But I have to tell mine that I'm done with that part, and then I'm dividing by x. So when I graph this, I get kind of a weird, we call it a step function. So the left end is coming into here, and then the right end is going out there. And the reason I left these open is that I can't have 0 since it's on the bottom. So this is my graph. So even without looking at the table, if I came in from the left towards x is 0, my y value would be -1 because all of these are -1. If I came in from the right side over here and came towards x value of 0, my y value would be a +1. If you really love the table, you would say second table set 0 because that's the number we're interested in. And then you'd go back to second table, scooting up, and you're going to see that really it's not approaching anything. It is -1 on the left. It is +1 on the right. So since our left and right side limits aren't equal, just like up here, the limit to this function up here does not exist. And that's your answer, does not exist. Because the left side and the right side limits are not the same. The grand finale of 11.1, so exciting. If I plug in a 0, I know I'm in trouble. 1 over 0 squared is undefined. So I'm going to go right to my graphing option, get rid of this. I'm going to go with 1 divided by x squared, and I'm going to have a graph that looks kind of like a volcano. So it's going to go up here, and it's going to go up here. This goes down there forever. So I can see that the ends are going down towards 0, but it doesn't ask about the ends. It asks as x goes to 0. So from the left of 0, when I go towards 0 for an x, my y or my graph shoots straight up, which is infinity. If I get to the right side of my 0 and I head towards x equals 0 but follow the graph, it also goes straight up to infinity. So because the left side equals the right side and they both approach infinity, I would say that the limit as x goes to 0 of 1 over x squared is infinity. Now clearly they're never going to get to infinity, but you can see as you close in on 0 from both sides, they're both headed up towards infinity, and that's what limits are. What are you approaching or going towards? Not what do you actually necessarily get to. Isn't that fun? All right, you got yourself a worksheet, and on Schoology, there's a place to type in your answers. Be careful if they're decimals. It does tell you how to go about that. And then by Friday, you want to send in a picture of any work that you did as well. Awesome. See you guys.